I guess
let's name it properly.
Yeah.
So incredible, because you've talked about taking how many terabytes of data down to a couple of gigabytes.
So actually, this is probably one thing that I wanted to talk about quickly.
Please, yeah.
The easiest way for us to communicate has been speech. It's what we're doing now. Text has been harder, but you've seen with ChatGPT, it's now easy. You just ask it to rewrite your kind of emails. And with Office 365 and Workspace, it'll do that. And visual was the hardest. These have all been flattened by this technology now, so we can communicate anything. But the technology behind it, as you said, was a bit crazy. To do this, what we did, so Stable Diffusion was our text-to-image model. We were like, do we do it big and do loads of layers, or do we make it accessible? And we were like, accessible. So we worked super hard, Manhattan Project, and we took 100,000 gigabytes of images, 2 billion, and created a 2 gigabyte file that can generate anything.
Okay, let's slow that down, because the meaning of that is insane. How many terabytes was it?
It was 100 terabytes,
yes,
100,000 gigabytes, and the output was a 2 gigabyte file that can create anything.
And that 2 gigabytes is, sits on your phone, your laptop, in your brain.
It was the whole stack. So intelligence is compression. You're going to go away from this event, and you're going to compress the things that you learn and have key takeaways, right? That's what we do, and that's what these machines do now. But again, it's a single file. 4 of the top 10 App Store apps in December were based on Stable Diffusion. And it was the entire stack. A single file of weights, of numbers.
That's extraordinary.
Words go in, images come out.